This lesson is about proportional relationships and graphs. Previously, we learned that in tables, you can tell if you have a proportional relationship by looking for equivalent ratios or by looking for a constant multiple. Today, we will learn about how we can tell if we have a proportional relationship in a graph.
A graph can also be used to show a proportional relationship between two quantities. The table shows a proportional relationship between time and the number of heartbeats. Each row of the table can be represented as a ratio. Each ratio can also be represented as a point on a graph. Draw a line through all of the points. Each y value is 3/2 times the x value. This means that every time the x value increases by 2, the y value increases by 3. Notice that the line passes through the origin. A graph that represents a proportional relationship is a straight line passing through the origin.
Okay, so in order to tell if a graph represents a proportional relationship, it must be a straight line and it must pass through the origin. The origin being the point 0, 0. We talked before that proportional relationship would have a constant multiple. Well, if we were to add 0 to our table and we were to multiply it by anything, we would get 0. So we need to have that point 0, 0 as a part of our graph if we're going to have a proportional relationship. He mentioned in his explanation that every time the x value increases by 2, which in this time increases by 4, the y value increases by 3. So in this time by 6, since it's 2 times, 3 2 times. Just pointing out that you really do have a very solid pattern whenever you're dealing with proportional relationships. Okay, so we need to check for two things whenever we look at a graph to tell if there's a proportional relationship. We must have a straight line and it must pass through the origin. So we'll look at each and see if you can decide which graphs have a proportional relationship. A is a straight line and passes through the origin. B is a straight line but does not pass through the origin. C passes through the origin but is not a straight line. We must be a straight line and we must pass through the origin in order to have a proportional relationship. Does this graph show a proportional relationship? This graph is a straight line, but it does not pass through the origin. So we would say no, and it does ask us to explain. Does this graph show a proportional relationship between x and y? No, again. We do not have a straight line. Just to kind of maybe look at an example. Remember that proportional relationship would have a constant multiple. So let's say that our constant multiple is 3 times 3 times 3 times 3. So this has a proportional relationship. If we were to graph it, if I can do this neatly, we'll have this go by 2s, and this go by 1s. so you get the idea. 2, 6, 3, 9, so that'd be 4, 6, 8, would be right in here. 4, 12, that'd be 8, 12, right here. If we graph this, we can see that straight line forming. If we add a, maybe a pattern, but the numbers were not proportional. Like there wasn't a constant multiple. Maybe this one's times 2. This one's times 3. This one's times 4. Let's try one more. This one's times 5. We do have a pattern. If we were to graph it, again, I've got to try to be neat here. These will go by ones. And we'll do these by 2s again. We would see that because it's times 2, then times 3, then times 4, then times 5, we don't have that constant multiple and it's growing bigger and bigger every time. That if we were to graph this, you would see that each time it would get higher and higher faster. And it would not be, this would be somewhere up here, it would not be creating that straight line, but it would actually be curving because it's getting bigger and bigger faster. This is just to give you a visual. Whenever we have that constant multiple, it really is going in a straight line. Does the equation y equals 6x show a proportional relationship between x and y? Well, we need to create the graph. It's not made for us yet. So on your note sheet, I give you a table to work with and a graph to fill out. Whenever you create a graph, you can use whatever x values you want. You might as well just use easy values. And you want to use a few so that you can get a real good picture of the graph. Now this equation or function rule is telling us to always multiply our x value times 6. So we would do 6 times 0, 6 times 1, 6 times 2, 6 times 3. And each time we would get our output value or our y value. This creates a pair, x with y, 0, 0, x with y, 1, 6, 2, 12, and 3, 18. This gives us points to work with and we can place them on the graph. Now, you can go by whatever you want, just you can't mix it up. You gotta, if I'm gonna go by ones, I gotta keep going by ones all the way across. And then here, I think maybe I'll go by 2s, as long as I do it the whole way. Here's my y, here's my x. Okay, so plot out these points, 0, 0, 1, 6, 2, 12, 3, 18. We're getting a straight line, and we're passing through the origin. Let me get that a little bit better. So we could say, yes, we have a proportional relationship because it's straight and it's through the origin. Okay, let's try the next one. Again, I provided you a table to fill out, which can kind of just help you organize your work, and a graph to work with. If you aren't given a graph, you have to create it. Okay, this rule tells us that we'll take our x value times 4 and we'll add 1. I like to put the rule here, it just gives me some space to work out the problem. So I get to choose whatever x values I want. I might as well choose easy ones. 4 times 0 plus 1 would be 0 plus 1, which is just 1. So my x value is 0 and my y value is 1. 4 times 1 plus 1 makes 5. 1 with 5. 4 times 2 plus 1 makes 9. 2 with 9. And 4 times 3 plus 1 makes 13. So 3 with 13. So we put these values on the graph. Again, I think I'll go with 1s along the x-axis and 2s along my y-axis, just so I can fit everything in. All right, 0, 1, 1, 5, 2, 9, 3, 13. Connect my dots. I am getting a straight line, but it does not pass through the origin. It actually passes through at 1 rather than 0, 0. So I would say that no, this does not show a proportional relationship because it does not pass through the origin. Last part. Sometimes we can just use our graphs to answer questions. This graph does show a proportional relationship, and we can see that it goes through the origin and is a straight line. We just have some questions to answer. What does the point 1, 90 represent? 1 second, that's our x value, x comes first, 90 feet. So that means that the cheetah is running 90 feet for 1 second, or 90 feet per second. That's our unit rate. Question B, what does the point 0, 0 represent? Well, that would be 0 seconds, 0 feet. If no time has passed, if we're right at the beginning, the cheetah hasn't had any time to run, then it's not going to have gone any distance. That makes sense with this problem. Part C. How far did a cheetah run in 3 seconds? Well, let's find 3 seconds. Up to our line. Over. Looks like 270 feet. And lastly, assuming the cheetah continues to run at the same speed, how long would it take the cheetah to run 900 feet? 900 feet is off our chart, but we have a useful value here. We have the unit rate. If the cheetah is running 90 feet per second, we can pretty much figure out how far it goes with any amount of time to know how much or how long it would take to get to 900 feet. That would be times 10. So that would be 10 seconds. All right, the graph shows the proportional relationship again. You want to know how many pounds of dried fruit there are per pound of nuts. What point represents this unit rate? Well, to get the unit rate, we want to know how much for 1 pound of nuts. That would be the point.